Welcome to the quadratic function series. In this video, we shall learn how to solve quadratic inequalities focusing on a solving approach. Let us look at the behavior of a quadratic function with x-intercepts. The plotted graph shows that the x-intercepts are x equals to -1 and x equals to 3 respectively. These x-intercepts are obtained when we let y equals to 0 and solve the factorized quadratic equation. Furthermore, we notice that when x is less than -1, say x equals to -1.5, the value of y is positive 2.25. When x is between -1 and 3, say x equals to 1, the value of y is -4. When x is greater than 3, say x equals to 3.5, the value of y is positive 2.25. Evidently, apart from the critical values of x equals to -1 and x equals to 3, where the corresponding values of y are 0, the function produces either positive or negative y values everywhere else. We also notice the alternating value of the function y going from positive to negative to positive as x increases from left to right. With these fundamentals now, let us look at an example of a quadratic inequality given in the factorized form. We will use a four-step solving approach. In step 1, we will find the critical x values. In step 2, we mark the critical x values on a number line. In step 3, we will do a sign test. To do so, choose a value in one of the three regions. In this case, since 0 lies between -1/3 and 5/4, and is also easy to compute when substituted into the expression 4x minus 5, 3x plus 1, we will let x equals to 0 and test for the sign of the expression. Substituting x equals to 0 produces a value of -5. Thus, we know that for x values between -1/3 and 5/4, the expression gives negative values. Using the alternating pattern of the quadratic function, complete the sketch. Since the question wants to know for what values of x is the expression positive, we will look at the corresponding section of our sketch. In step 4, we will get our solution range. Look at the section above the number line. As the lines are disjoint, the solution is the disjoint range written as x less than -1/3 or x more than 5/4. Let us practice with another question. In this question, solve x plus 3 times 1 minus 2x greater than or equal to 0. Pause the video here and write your solution before comparing answers. To solve this quadratic inequality, step 1, find the critical x values. Step 2, mark the critical x values on a number line. Step 3, do a sign test. In this case, x equals to 0 remains a good value to substitute to test for the sign. Use the alternating pattern of the quadratic function. Complete the sketch. Step 4, get the solution range. For the expression more than or equal to 0, we are looking at a part of the sketch above the number line. As the sketch is a continuous joint line, the solution is written as a joint range. The answer is x is more than or equal to -3, but less than or equals to half. In our last example, we meet a quadratic inequality given in a general form. Pause the video and ponder what you could do to solve it. In this case, we begin by manipulating the quadratic inequality to a factorized form. Using the four-step approach, and in particular for this case, we are looking at the region that is below the number line. Since the sketch is a continuous joint line, we write our solution as a joint range. The answer is x is greater than or equal to -3/2, less than or equal to 1. Here's a summary of the solving step. I hope you have learned something from this lesson. See you in the next video.